This Steel Profiles podcast is brought to you by AISC Continuing Education. The new spring seminar schedule has just been announced. Register early for best pricing. Visit aisc.org/seminars to find a seminar in a city near you.
Welcome to another episode of Steel Profiles. I'm your host, Margaret Matthew, Senior Engineer in the Continuing Education Department at AISC. Our guest today is Dr. Duane Miller, Manager of Engineering Services at the Lincoln Electric Company, Cleveland, Ohio. Dr. Miller earned his bachelor's degree in welding engineering from LeTourneau University in Longview, Texas, a master's degree in materials engineering from the University of Wisconsin-Milwaukee, and was awarded an honorary Doctor of Science degree from LeTourneau University in 1997. An American Welding Society member since he was 19, he currently serves as chair of the AWS D1 Structural Welding Code Committee and is a member of the Technical Activities Committee. Duane is a member of the AISC Specification Committee, a licensed professional engineer, and is both a certified welding inspector and a certified welder. Dr. Miller is a recognized authority on the design of welded connections and is in demand as a speaker on the subject all over the world. He publishes frequently in the industry press and on 3 occasions has been awarded the coveted Silver Quill Award of the AWS for the excellence of his published work. He has authored chapters of many texts, including AISC's Design Guide 21, Welded Connections, a Primer for Engineers. In 2001, he received the AISC T.R. Higgins Lectureship Award, and in 2005, he received AISC's Lifetime Achievement Award. Welcome to Duane Miller. Thank you so much for taking time out of your busy schedule to talk to me today.
You're welcome, Margaret.
Okay, so we'll just start off with the easy ones. How did you get involved in the welding industry?
The answer to that really starts by understanding a little bit about my undergraduate work. I went to LeTourneau University in Longview, Texas. They're one of the few schools that has a program that offers a degree in welding engineering. And in fact, I went to the school as a mechanical engineering major, but was kind of intrigued by this welding program that they had. I was intrigued because it was unique. I got to campus, there was a lot of enthusiasm about the program. I rather liked the hands-on aspect of the program. But maybe the biggest draw of the program was they had a 100% placement rate of graduates from the welding engineering program. And I didn't go to college so much to get a degree, I went there to get a job. And I actually had a high motive to get a job. Had my high school sweetheart that I wanted to get married to.
Oh, well,
so
that's good motivation.
That's why I pursued welding engineering, but also continued on in the mechanical program and got a double major.
Oh, okay. I did not know that. That's not in your bio when we read it.
I did. I guess I don't broadcast it.
What do you think's been the most significant change to the welding technology in your career?
Well, in my business, there may be 3 major parts of welding technology. There's the power supplies, there's welding consumables, and then there's the mode of application. And all 3 have changed remarkably.
Have they?
In the power source side, we've gone from basic electrical rectifiers, transformers, kinds of systems to now computer-controlled power supplies, where you actually program them with a PC to get the output that you're looking for. And that's really revolutionized the arc and given us much finer control over the welding arc than we've ever had. In the consumable side, we have a much more consistent consumable today, whether we're talking about control of mechanical properties, control of hydrogen, control of the arc. There have been tremendous advances in that area. And then in terms of application, robots, when I joined the industry, were just a concept, and today they're widely used. The precision that we can get out of welding is so much more advanced than when I joined the industry just 30-some years ago.
So how long have the computer applications been around?
The last dozen years or so is when that really took off, and even the advancements in the last 5 years have been pretty remarkable.
I know that you're a certified weld inspector and a welder. Are you a good welder?
I'm a good welder. Excuse me. I'm an okay welder. I used to be a good welder. I used to I could say I was an excellent welder. When I joined the company in my first job, when I was in sales, and even my first part in our welding technology center, I used to weld almost every day.
Oh, you did?
And but welding's like any other skill. You have to stay at it. And now most of my welding's at home. And I just don't do it as much as I used to.
What do you weld at home?
Oh, anything that's broken. I think my last project was repairing the bed of my truck that was rusted out. So once you have a welder, it's amazing how many things need welding, and moreover, how many friends you have that have things that need to be welded. That really goes up when you know how to weld. You've got a lot of friends who have projects.
Absolutely. That's a good friend to have, someone who can weld.
There you go.
You've been at Lincoln Electric for over 30 years.
32.
Where you've worked with Omer Blodgett, a legend in our industry. What's the most important thing that you've learned from him?
Oh, the most important.
Or anything, really.
Thank you. I can handle that better. So many things. I suspect what probably surprises people most when they're working with Mr. Blodgett, a man of his acclaim, and he's such a humble individual. And his respect for others, his giving nature. I'm not sure I learned as much about that as I should have, but he certainly exhibited a humble nature that was very, very impressive. He really had an admiration for those who have gone before us. And he used to always talk about standing on the shoulders of giants. I thought that was his saying, and then I found out that Isaac Newton used that phrase. If I can see a little further than others, it's because I'm standing on the shoulders of giants. And so his admiration and respect for some of the other individuals was immense. And his approach to problem solving was always interesting, very cautious. What might have seemed to be the obvious solution so often turns out not to be. And he was always very reluctant to sign on to the early solutions. And I think that has served me well to be very introspective about jumping onto the commonly accepted view initially.
Do you have any other Omer stories you want to tell?
Other Omer stories? Sure. Among other things, I remember we'd go into meetings with customers' problems. We'd start talking about troubleshooting. And he had such a simple saying. He used to start out by saying, now we're going to do a little troubleshooting here, brainstorming, and there's no dumb ideas. And humbly, he used to always say, now I don't know anything about what you're doing, so you're going to have to tell me about this. Now, I knew good and well he knew much of the background, but it always put people at ease.
Yes.
And they would tell their story. And that was always helpful as he dealt with that. I also remember that he always had a tremendous sense of obligation. And he said, these folks came in, they spent a lot of money to come visit us today. He said, we've got to come up with a solution. It was like this gorilla was on your shoulders. You had to solve the problem. There wasn't any just sitting down and we're going to chat with these folks and drink a cup of coffee and shake their hands and say goodbye. We had to come up with a solution. There was a seriousness about his approach to things, and I thought that was very, very helpful. Mr. Blodgett was always a big one for involvement with committees.
Excellent. We always like to hear that.
And he encouraged me to get involved with both AWS committees and AISC committees, and that advice has certainly served me well. He encouraged me to write papers. And I remember as a rookie going to him and I said, well, what should I write about? And he said, well, find something you don't know anything about. And he said, believe me, after you commit to write a paper about it, you're going to know something about it. That was that was anti-conventional wisdom, right?
Yes.
You'd normally find an area of your expertise. But
right, that you already know everything about.
Yeah, and he'd encouraged me to dive into something that maybe wasn't so well defined. And so I thought that was good advice, too.
You probably learned a lot.
I did.
That's where all your expertise came from.
Well, a lot of it did, sure.
You brought up AWS. Let's talk about that. You're very involved with AWS. So recently, AWS converted to a 5-year cycle with its documents.
That's correct.
What role did you play in that, and did you lead the charge in that?
Well, it was a group effort. In fact, I've thought for many years it would be desirable to get off of the 2-year cycle. In fact, the AWS board had established a policy that said that the D1.1 code needed to be published every 2 years. It was driven by financial concerns at the time, and I rather rejected that premise, focusing rather on what would be good for the industry. What I had heard is ongoing complaints about the changes every 2 years, keeping up with the changes. And of course, there was this whole coordination of issues with coordination of publication editions with other standards. And with AISC on nominally a 5-year cycle, we went over to advocate the use of the same 5-year cycle for AWS. And Ray Shook, who's now the current AWS executive director, agreed that the policy was ill-founded, that had been established before his time. And he said we should do what's the right thing for the industry, not be concerned about that financial stream. And so we were given the green light, and the committee decided 5 years was the right interval. I have a feeling maybe it's going to become 6 now that the IBC has looked at that interval, but that's the nature of the change. I also would like to mention Bill Millick, who, of course, just recently passed away. But I remember Bill one time saying that the value of a standard is reflected in its longevity. And if that's a true statement, and your code was being republished every 2 years, what does that say?
Exactly.
And so I think that the 5-6 years is the right move, and so we'll give that a try for a few years.
Very good. Everybody's always happy when there's longer and longer time between publishing of all these codes. Let's talk about the Northridge earthquake. I have intelligence from AISC that on the anniversary of the Northridge earthquake, somebody in my organization gets an email every year. And he told me to ask you about it. So what do you think the importance of the Northridge earthquake is, the impact that it's had on our industry?
Well, it's been huge, and I think there are very positive elements of it. And I need to say there are also some negative impact, and I think the negative impact, frankly, is not well deserved. There's a perception that steel buildings did not perform well in Northridge. I don't think that's correct at all. If you review the history, I think the early publicity that many people reported hundreds of damaged buildings. And when the dust settled and the incomplete fusion issues in the root that were detected after the earthquake, the so-called W1A defects, were not earthquake damage at all. And when you subtract that out of the database, you find that the damage was concentrated in a relatively few buildings. None of them collapsed. Nobody died in a steel frame building, and most of them were repaired and put back into service. I think it was a great record. Now, the system didn't work as expected, and so it was a problem that needed to be investigated. But what came out of that, I think, are far superior systems that will be more reliable in future earthquakes. And so the net effect is, I think steel will be even a better system in the future than it was in the previous one. So it had a huge impact on our industry.
We learned so much.
We really did. We really did. And I think the industry is much more aware of welding-related issues, weld details, backing, weld tabs, weld access holes, much more cognizant of welding procedures, welding processes, some of those variables. I think as an industry, there's a much broader understanding of the role of fracture. What I am still disappointed with is the number of people who seem to think that the avoidance of fracture is a guarantee of ductility. And that's not necessarily, that's not the case. That's not the case. Two different phenomena. And I fear that there's still some people who haven't mastered the concepts behind ductility, but it was certainly a major change in our industry. And on January 17th, every year I tend to send out an email to my colleagues who worked that problem on the anniversary of that event that was, 17 years ago, this upcoming January.
Yes, 1994. And you were actually appointed to chair AWS's Presidential Task Group on Northridge earthquake issues. So, I mean, obviously you know a great deal about this topic. So is that why, because you were the chair of this task group?
That's a good question, Margaret. It actually, I think I have to go back. We have sales offices all across the country. Mm-hmm. And our Los Angeles office is one of the larger ones, and that means you have more experienced managers out there. And the manager at the time of the earthquake was a gentleman, Ed Morgan. And Ed called me up 2 or 3 weeks after the earthquake. And he said, Duane, have you heard about the damaged buildings, steel-framed buildings, from the Northridge earthquake? Now, all the news was about the concrete bridges that had fallen down. Mm-hmm. And, of course, they were very visible. They had had very dramatic impacts on the transportation in the LA area. And that's what people were focused on. And people were talking about rapid replacement of bridges, and some of us wanted to see steel bridges in as replacements. And that was the technical discussion, not buildings. Mm-hmm. We had seen the tilt-up slab construction and timber construction, and we had seen some of the concrete structures that had collapsed, but nobody was talking about steel. I said, Ed, no, I haven't heard about this at all. And he said, you ought to get out here. He said, I'm selling equipment to people that are going in and repairing these buildings at night. And Ed sounded like this was something sinister. In fact, it wasn't sinister at all. It was practical. The buildings were occupied during the day, and people would evacuate and weld at night and patch the building back up for occupation the next day. But Ed didn't know that. He just knew they were going in at night. And he said, you ought to come out here. One thing led to another, and I went out and I visited 6 sites. It was quite a day. And I quickly came to an assessment that it was a design-related issue. And I was in LA on a Friday and came back over the weekend. And on Monday, I called AISC. And today, I don't remember whether I called Neil Zundel or Jerry Heyer. But I said, do you gentlemen know about the damaged buildings from Northridge? And whoever I talked with didn't know. I said, well, you ought to find out. And I told them where I'd been and told them what my initial impressions were. So that was in February. And then in March, there was a meeting that involved people, including building officials from Los Angeles, some of which who didn't know about the damage. 6 or 8 of us were asked to give firsthand reports of what we had seen. So that was my early on involvement. And you asked about the Presidential Task Group, and I'm trying to get to that, Margaret. Mm-hmm, mm-hmm. But over the summer of '94, a whole variety of well-intended but misdirected, misguided recommendations started coming out. And many of them were focused on welding. And because of some superficial characteristics of the cracks that occurred during the earthquake and similarities to underbeat cracking that can occur due to hydrogen and other factors in welding, there was a group of people who thought the solution was to increase preheat, to do post-heat hydrogen soaks, changing the welding processes, peening the welds. Several people thinking the steel specifications were the problem. A lot of focus on recycled steel and concerns about tramp elements in the steel. And my assessment was that wasn't where the solutions were going. Those weren't going to be the issues that led to solutions to this problem. And I was complaining to the American Welding Society that they seemed to be pretty inactive when this was going on out there and welding was taking a black eye. People were saying instead of using D1.1 structural welding code for steel buildings, we should be using D1.5 for bridges and using the fracture control plan. I complained over and over again, and somebody said, well, if something's going to happen, I guess it's going to be you, Duane. So you're chairman of this committee, and we need to put together a committee and look into these issues. And so we did, and frankly, one of the things I'm very pleased with is after the test of time of 15 years or whatever, looking back to when we issued that report, the committee was right on. And of the assessment of the various issues, I can't recall anything that was where the committee was wrong. Got it right.
We would expect nothing else from you, Duane. So what do you think? I mean, this had big impact on the code, and did it change a lot of things? The way that we look at least seismic welding?
The code. Big impact on AISC seismic provisions.
Mm-hmm. Yes.
And of course that generated CPRP, connection pre-qualification. Huge impact. Welding code?
Not so much.
Not so much. 2 or 3 big picture things that came out of that. Certainly some detailing, backing removal, and welding through access holes, and now some special tests to demonstrate welder skill to be able to do that. Provisions to demonstrate consistent toughness in the deposited weld metal. Certainly some hydrogen control measures that were implemented primarily because of some identified voids in the code. But those are the big ones.
We talked about Omer a little bit already. Other than him, who were some of your most significant mentors?
Perhaps in a chronological way. I got to start with the list with my dad.
Well, sure.
And my dad, who's still living, is a remarkable man. Dad was of the old school where you took responsibility for yourself and your own actions, and you were accountable. You did your best. And Dad had an attitude, there wasn't anything he couldn't do. He just did it. Somehow I think that came from his dad, my grandfather, who was a Kansas farmer. You had to do it yourself. First, you didn't have money to pay anybody else to do it, but somehow you just kind of figured out a way to get it done. So my dad was still is a huge influence on my life. When I went to LeTourneau, one of my professors was Dr. David Hartman, and he eventually, while I was there, became the dean of the engineering department. The old dean had left, and Dr. Hartman had taken over, and he assumed the portfolio of some of the courses that the previous dean had taken. And one of them was an advanced engineering lab. And I had taken the basic engineering lab the semester before. I'd done well. And so now I was taking the advanced course, as well as the rest of my colleagues. And Dr. Hartman was teaching it for the first time. We submitted our reports, and we were all shocked. I think the class average was probably 50%. He absolutely shredded our reports. There was more red on the paper when it was all done than there was black, and I'd put the black on the white paper. It was unbelievable. That became report writing 401, if you will. And he, like no one else, taught me technical writing. Grateful to this day. I don't know if I learned anything about engineering experimentation, but I learned about report writing. He was unyielding in his demand for excellence. I appreciate that. And so he was a huge mentor. And then, of course, I joined Lincoln upon graduation, and the gentleman who interviewed me was Mr. Don Hastings. And Mr. Hastings at the time was vice president of sales. He went on to become CEO of the company. And Mr. Hastings had an unbelievable impact on my life. I think I would have been an engineer in a back room someplace and probably would have never accomplished anything similar to what I was able to do if it hadn't been for his tutelage. Mr. Hastings was the eternal optimist, the salesman of salesmen, wonderful public speaker. He would prepare his speech so well. It always came off as if it were off the cuff. He would practice his lines. He said, I'm thinking about starting this way. He said, what do you think? And it was just part of his MO. But he's a wonderful man, and so Mr. Hastings would be on that list. And then, of course, we've mentioned Omer Blodgett, but the other gentleman who I have an immense amount of respect for, and everybody in our industry knows, Dr. John Barsom. And I had studied his textbook in graduate school. So it was just an honor when I got to meet him and Stan Rolfe. Dr. Barsom and I were on a variety of committees together. He taught me about staying at Marriott hotels. And he was, medallion or whatever they call it. And then I became medallion because I hung out with him enough. And then we used to get together at the concierge lounge for breakfast in the morning. Mm-hmm. And I'd bring his book. And I'd have read a chapter, and I had all my Post-it notes in there of questions that I'd want to ask him. So over a bagel and coffee, we'd go through, and I'd say, John, I have a question about this equation. I have a question about this figure. And it was nothing. It wasn't patronizing at all. It was one-on-one tutoring. What a wonderful experience. And what a giving man. There's another humble man. and a world-class individual, and Dr. Barsum's a model for many of us.
You just mentioned public speaking. You are one of the most dynamic and interesting speakers I've ever heard. Is this something that you've always been good at, or did you have to learn how to be a good speaker?
The day I was born, I could speak like this, Margaret. Margaret, thank you. That's kind of you. I suspect I probably had gifting that way. I remember as a kid, my dad told me, son, if you have something to say, stand up, say it. He was a military officer, my dad was. A man of his word, he said it, and people listened and responded, and so that was probably an early example, I think, in my career. But then another individual who had a tremendous influence on me, Jerry Hinkle. Jerry Hinkle worked for Lincoln Electric and was manager of our application engineering department when I joined the company. And Jerry was a very, very skilled public speaker. And I asked Jerry one day what made him so good. And Jerry said, well, he said, I think I'm so slow that by the time I figure something out, I can explain it to anybody. And I suspect there was some humility. I'm sure there was some humility in what Jerry was saying. But what I took from Jerry, and I try to use this, is Jerry set out the steps of what you had to go through to understand something. Step 1, Step 2, Step 3, Step 4. And he was very disciplined in making sure that he walked people through and got to the right conclusion. And that was that had a huge impact on me, and I try to do that. I really do want my audience to learn, because my goal, of course, is to make sure people use welding as often as they can. They use it effectively. They get a dependable result that's economical, and I want them to learn. And Jerry helped me that way. And then I think the other, in the last item, I attend a church, Parkside Church, where the pastor is Alistair Begg. And Alistair Begg's on the radio around the world, 1,500 stations or so. But every Sunday I get to hear him. And I can't help but listen to anybody and try to pick up ideas and why did they use that technique or whatever. And he's a world-class public speaker. I'm sure I've gained from him.
So you're always honing your craft. You're always trying to learn how to be
Try to take something away from why did that work, or why did that not work. Try to refine it.
You've gone from being a protege in our industry to being an expert. What's it like for you to now have proteges of your own?
Well, it's very natural because, again, Mr. Blodgett, his philosophy, we're standing on the shoulders of giants, he viewed his expertise as something he held for a time and was going to pass on to somebody else. And I liken it to something you inherit. I have my grandfather's shotgun. Mm-hmm. Someday one of my kids will have it. I need to care for it, and then I'll pass it along. If I don't care for it, they're not going to have anything. I think this knowledge that we've assumed is something to be transferred along, and I see that as part of the obligation. Somebody gave it to me, I need to pass it on to somebody else. Mm-hmm. I think it's very natural to do that.
Who are your proteges at the moment?
Well, in fact, we are looking to hire a couple more at Lincoln.
That's good to know.
If anybody's listening is interested, let me know.
Oh, you might have a lot of applications now, Duane.
That'd be fine. Informally, I have many at Lincoln. I get to work with our new hires and get to talk to them about how they work with my customers and how they solve problems, and I lecture them about things that they should absolutely never do. And
how big is your engineering staff at Lincoln?
We probably have 300 or 400 engineers in all the various groups, at least for our Cleveland-based operations, and we have operations around the world, and I assume it would be about double that. And we hire usually 20 or 30 new engineers a year, and so I get to talk with them. And then right now, as the AWS D1 committee chair, I'm highly cognizant of our volunteers, and I try to coach them along the lines of what do we have to do to make good use of the volunteers' time and make effective changes that will benefit the industry.
You've said a leader is a person who knows an outcome, has a plan to get there, and can convince people to follow. Are you thinking of anybody specific when you say that?
Well, you have it almost right. You have the essence of it. I say that they know where they're going, they know how to get there, and they can persuade others to follow. And so the first part of that has to do with vision. Where are you headed? What are you going to do? What does it look like? How to articulate that vision to the masses. How to get there. Strategy. How are we going to accomplish what's the task at hand? And then, of course, persuasion, and that's where Don Hastings was a big influence in my life. How do we get others to come along? It has to be a reasonable goal. It has to be a commonly held goal. They have to see it as achievable and get people to come along. Now, I think you asked me who was I thinking about, right?
Yes. Did you have somebody specific in mind when you say that?
Ronald Reagan's my hero. I think he was quite a leader. We're learning more and more about him as his diaries. Mm-hmm. In the privacy of his bedroom at night, he's writing down his thoughts. And now when we look back at him, there was a man who had a strategy and was looking at what he has to do. He had a vision. Mr. Gorbachev, tear down this wall. It happened. Mm-hmm. It happened. So I find him to be a fascinating leader. But a lot of our leaders, and I think not coincidental at all, military people and coaches. And so we think about people like Lombardi and Landry in the coaching arena, and John Wooden from UCLA. I know John Wooden one time said, "I've never scored one goal as a coach." And I think that's representative of the leadership role. He knows that's not his job. Mm-hmm. He needs to motivate others and help them do that. And then the other group, military leaders. Recently Colin Powell and Eisenhower and a lot of their writings. So those are some of the people that I've studied.
So what lessons in leadership can you offer?
Well, I think it goes back to those three. First, what's the vision? One of the big challenges is to simplify a vision, make it easy for people to understand. Martin Luther King, I dream of a day where my children will be evaluated not by the color of their skin, but by the content of their character. Wow, very clear vision mm-hmm. of what he hoped for. So the vision is critical. Many people don't stop long enough to think through the vision and how they're going to articulate that. The second component, how to get there, many people don't do that either. What are the steps we're going to have to go through? Where are going to be the obstacles? Some general, and I don't know who it was, said a battle plan's only good for 24 hours. Absolutely. Things change. We have to adjust. That's part of that strategy. And then getting others to follow. You have to kind of know where people are coming from and where their concerns are. Reasonable people don't sign on to unreasonable tasks. People aren't going to sign up to visions that aren't shared. And so that's all part of leadership. And then I have something I call the cost of leadership. And part of the cost of leadership is you're going to be criticized. Mm-hmm. If you're a leader, there's going to be all kinds of people line up to tell you why you're wrong and why it's the wrong way to do it. And so you got to have a stomach for that. Mm-hmm. General Powell said, command is lonely. That's part of the cost of leadership. So that's part of it.
You once mentioned that problem solving is the most difficult mental task. What are some of the more interesting problems that you've had to solve over the years?
I was quoting a psychologist who said that. I think problem solving is difficult because we don't know where it's going to take us. There's not a prescribed course. There are people who say they have problem solving techniques, but I think all of them let us down because there's just not always frequently isn't a clear path. Most interesting. Northridge was a huge multi-dimensional challenge, mm-hmm. Problem. I've been involved with some major committee activity. I was chairman or co-chairman of the AWS Bridge Welding Code when we put together the fracture control plan. Mm-hmm. And then we've already talked about the Presidential Task Group, and then eventually that led to the Seismic Welding Supplement, D1.8, and those were big challenges. One of the more intriguing problems, and my customers do all kinds of things, including make snowmobiles. One of my customers manufactures snowmobiles, had a problem with a muffler system. And they had tested this extensively in their laboratory, thought they had a reasonable depiction of field loading, and it had passed all the tests in their lab. They put them into service, and after about 200 hours, they started getting these failures. And of course, the failures were, quote, in the weld, end quote, but really in the welded connection. Mm-hmm. at the toe of the weld, and I started getting these photographs. And for the life of me, I couldn't figure out what was happening. Eventually, I said, I really need some pieces. And so they sent me some assemblies, and I started looking at the assemblies. And I realized that on this assembly, there was a second bracket that was breaking. And it turned out that the second bracket was actually the primary fracture. And everything that everybody had been focusing on was a secondary fracture after the first had occurred. So seeing the bigger picture was key here. And then we found out that this primary bracket that was failing had never been tested. It had been added after the fact. And so it was a challenge because I had misinformation. Mm-hmm. I had been told and assumed what was fact. It turned out not to be fact.
I would think that would probably happen a lot in what you do.
I always assume that some of the information people is given me as fact, that some of it's not. And we got to. There's always missing information. That's a given. Mm-hmm. But there's usually misinformation. What people think is fact isn't.
That's probably a lot of what your job is sifting through that to figure out what is and isn't actually happening.
Another interesting project, I won't name it because most people would know what I'm talking about. There was a major sports stadium that was erected recently. I was asked to get involved because there were hundreds of bad connections, hundreds of bad welded connections. So we got together at the job site, we're sitting around the trailer, and I'm listening to the reports from the inspection agency. And what I know is the number of reports are in the dozens, not in the hundreds. And I went up to the whiteboard and I said to the audience, I said, gentlemen, I'm a little bit slow. I said, I'm not getting this. I said, it sounds to me like we have 4 kinds of problems that I heard described, and I labeled them or identified them as A, B, C, and D. And I said, now, was there anything other than A, B, C, and D's? Everybody agreed, no, everything we talked about so far fit into one of those 4 categories. I said, now, how many A's did we have? They rifled through the reports, and there were like 8 A's. I said, okay. And I said, how many B's do we have? Well, there's 6 B's. All right. And I said, how many C's do we have? And they said, well, counting the ones that are B's? And I said, no, C's are defined differently than B's. They said, oh, well, then we have 2 less B's, and we have 2 C's. I said, okay. I said, now, what about D's? Well, we agreed there was 1 D. So now the hundreds of problems have now boiled down to 2 dozen. And I went back and I said, now, if all we had was A's, I said A's have to be fixed, but we wouldn't be having this meeting if all we had was A's, right? Everybody said, yeah, A's are kind of routine, it's no big deal. I said, what about B's? Well, they're a little bit more critical, but you're right, we wouldn't have brought in all these consultants and we wouldn't be here. And I said, what about C's? They said the same thing. We wouldn't be. I said, so what we really have is 1 D, right? They said, yeah. I said, well, why don't we just work on D?
And that was just one connection.
One connection. One connection. Now, there's more to the story than what I'm telling you. But
it's amazing how quickly it all gets blown up out of proportion.
People are very concerned, and this 1D was of great concern. Mm-hmm. And that got fixed. And the project went along and worked out well, but it was sifting through and getting to the facts, and the fact wasn't hundreds of bad connections.
Mm-hmm. You may have already answered this, but what were some of your most challenging projects, or the ones you've talked about? The most challenging, or were there others?
Yeah. Challenge was usually ones with people issues.
Yes.
And the one about the sports stadium, clearly there were people issues, and those who were making the claims of hundreds had to eat some crow. Mm-hmm. And so that's a challenge. And so that was challenging. There have been others. Sometimes it's misinformation, sometimes it's information you don't have. There was one that was particularly rewarding because it was for Lincoln Electric. We had a piece of machinery in our own operation. It's used in manufacturing flux, especially a piece of equipment custom made for us. And the general details were that we had paid half of the amount before we received the equipment, and we were going to give them the other half. It was agreed upon that we'd pay the other half after it had been in service and operating trouble-free for 2 or 3 months. Well, this never did work. We got 2 or 3 weeks of service out of it, and it started self-destructing. And the manufacturer came in and repaired it by welding, and didn't do a good job with the repairs, and those started breaking. So every 2 or 3 weeks they're in fixing this machine. And this went on for about 6 months, and they said, it's yours. We're not fixing it anymore. You don't have to pay us for the other half, but it's your machine. And so this is about the time the maintenance department called me because it was out of commission, and they said, we need this machine up and running. And we got to have it running on Monday morning, and this was Friday afternoon. And they said, and we got to buy a replacement, and we can't get the replacement in here for 3 weeks, so we need to get 3 weeks of use out of this machine. And so on Friday afternoon, I started working on that, and again, there were a lot of unknowns. And I proposed a repair, and they said, that's about a week's worth of work, and we've got 2 days. And I said, okay. And so then we came up with another scheme, and it had about 3 days worth of repair. And I said, gentlemen, we're going to have to, we're not going to run Monday. We're going to fix this thing Friday, Saturday, Sunday, Monday. I said, we can't do anything more about that. And so I was cutting into their production. I said, but if we don't do it right, we're not going to get 3 weeks out of this thing. We've never had 3 weeks uninterrupted run on this thing from the beginning. And so Saturday, they cut into it and found out that my concerns were well-founded. There was far more cracking in this thing than we had, fatigue cracks, far more than anybody had suspected. That was gratifying because I had spent a lot of the company money with this alternate repair. And we got it fixed and went into production on Tuesday, and it ran for about 3 months.
Wow.
Uninterrupted. And then they found some other things. I said, folks, you were supposed to replace this after 3 weeks. He said, well, after it started running so well. I think we got 9 months out of it before it was all done. But it was fun to, most of my stuff is for our customers. Mm-hmm. It was something good to do something for the company and return some back home.
And to see how it all played out.
Right.
What were some of your most fun projects?
Fun projects are usually when I have a customer who's really grateful and appreciative. Had a customer made a product. They had some problems with Generation 1, and they redesigned it and brought out Generation 2 2 years later, and it didn't work too well. And then they brought out Generation 3 to solve the problems with Generation 1 and 2, and it didn't work very well. So they asked me to get involved with that. I'm deliberately being a little vague as to what the product is, but they had just sent out Generation 3. The product was supposed to last about 5 years, and it was lasting 10 months. And so I had to respond fast. They called me on Friday. I was there on Monday. By Monday afternoon, I had kind of figured out the problem, and by Tuesday evening, we had a solution conceptualized. 2 weeks later, they had a prototype built and put it into fatigue testing, and after 6 weeks they had better accelerated fatigue test. After 6 weeks they had better life than they'd ever seen with any of these other kinds of systems. And so that was particularly gratifying because this was a multi-year, multi-million-dollar problem for them. I appreciate customers who are loyal to us when we help them out and they convert their business over, and we benefit. We have a mutually beneficial relationship. So that's a particularly rewarding one.
What's your best advice for engineering students?
That's a great question, Margaret. First, and I guess I'm getting old enough, and the little hair I have is gray enough that I can start talking like an old guy. Young engineers today are coming out with a better set of skills than their supervisors have. And they know more about computers and programs and software and what can be done, and they can do more faster and without question. But my advice would be learn to respect experience. Learn to respect intuition. You may not be able to put in an equation to intuition, but intuition is really important, really important. So learn to respect that. I'd also encourage young engineers to do both, focus their career in a narrow area, but also broaden their area of expertise. Bill Thornton says, you can't know everything, and if you never learn anything more, you're just going to want to get paid more to do something that a graduate from college can do. He says, so become a specialist. And of course, he encourages people to specialize in connections.
Yes.
But I think specialization is important. Dig deep, deep, deep into one specific area. But while you do that, you also broaden your career. Learn more about materials. Learn more about non-technical things, sales, finance. Learn about areas that are important to your employer that may not be in the core area of responsibility of technical folks. It will serve you well. Read Petrosky. Everybody should read Henry Petrosky's books. Start with To Engineer is Human. I think Petrosky should be on everybody's reading list. Get involved with technical committees. You'll meet these giants we're talking about. Your base of contacts expands. You're on the leading edge of thought. I'd encourage people to do that. I guess that's enough.
That's pretty good advice. If you were not involved in the welding industry, what job would you like?
That's another great question. I think I'd have enjoyed a career in law.
Really?
I think I could have been a lawyer, and lawyers are involved with problem solving. I think good lawyers don't compromise on truth. I don't think you have to do that at all. So I would find that fascinating. I've always had a desire to pursue entrepreneurial activities, and it could have been almost anything, but that was certainly a desire. I could have easily chosen to have been a pastor. My oldest son is, and that would be a worthwhile pursuit, and I think I could have done that. I still may pursue this. Public office is something that's always been intriguing to me.
Really?
I think of dabbling on that when my career at Lincoln Electric's over.
What do you think about taking a run for?
That's part of it, because I don't want to spend years climbing the ladder of going through the systems, but frankly, to get involved with a higher level, either state government or, I don't know. I just don't think I'd do well as one of 400 people in the House or even 100 in the Senate. But I do think that I can offer some leadership that might be appreciated.
So you're going to set your sights high, it sounds like.
There you go.
Well, it'll be interesting to look forward to see how that all works out. You have a reputation as a great dad to your 6 kids. What child-rearing advice do you have?
Well, that's kind. I hope it's true. It's probably not politically correct. The best thing I did for my 6 kids is gave them a wonderful full-time mom. And Susan she's a wonderful mother to the kids, and I think my biggest contribution has been to enable her to be a mother. I think motherhood is underestimated, and I think that's another thing I did, is valued her contribution to the kids. I hope my kids feel that's true. The other thing, I think I provided an appropriate foundation for my kids. I think they're uniquely created. They have unique purposes for their time here on earth. And my kids know that, and they know that I believe that. And that's how I live my days, that I have a purpose that I'm supposed to accomplish. And I come to work every day to do my absolute best. So we have a finite amount of time here on earth to do that. Then we have to be ready for what comes next. I think providing that foundation to the kids has been very important to them.
That's excellent advice. I think that concludes our interview today.
Well, thank you, Margaret. It's been enjoyable.
It has been. Thank you so much again for taking time out of your busy schedule.
You're more than welcome.
This has been a presentation by the American Institute of Steel Construction. Next month's podcast features an interview with Louis F. Geschwender, former Vice President of Engineering and Research at AISC and Professor Emeritus of Architectural Engineering at the Pennsylvania State University. For more information on AISC continuing education opportunities, please visit us on the web at aisc.org/seminars. And remember, there's always a solution in steel.